Building a functioning, production-ready decentralized application that runs on the blockchain is no easy feat. You first need to write a smart contract that handles the application logic, create a front-end UI, and then seamlessly connect the two while managing interactions with the blockchain. Sounds like a daunting task, doesn't it? Well, what if I told you there's a way to simplify this process and accelerate your decentralized application development journey? Hello everyone, my name is Chris Kim, and today we're going to take a close look at the AlgoKit Fullstack template, exploring its contents and discovering how you can leverage it to build your very own decentralized application on the Algorand blockchain. Before AlgoKit, I vividly remember attempting to build a simple voting application on Algorand as part of my journey to understand Algorand development. But I have to be honest, the experience was far from enjoyable. I spent countless hours grappling with setting up my development environment, painstakingly configuring every component to deploy and test my smart contract during development. And then there I was, staring at a blank VSCode editor, feeling as if it were screaming intimidation right in my face. Now with the introduction of the AlgoKit Fullstack template, you'll be starting off with built-in deployment and testing features for your smart contract, alongside a fully functional front-end UI that seamlessly integrates with popular Algorand wallets and the default Hello World smart contract. The template will not only save you significant time during Algorand dApp development, but it will also provide references on how to optimally integrate your smart contract with your front-end UI. Without further ado, let's dive into a code demonstration that showcases the power of the AlgoKit Fullstack template and see how this template converts the once intimidating full-stack development process into an effortlessly streamlined journey. First things first, make sure you have your Docker desktop running in the background because we're going to be using this to launch our local network. Now go to your terminal and let's run AlgoKit init. Then it's going to show you a list of project templates that you can choose from. We're going to choose the Fullstack template. Here, name your template. I'm going to name it Fullstack Demo. And then it's going to ask you whether you want to choose the starter template or a production template. Now, starter template is good for simpler projects, while production template is more for complex projects that require CI/CD and other features. Now, because this is a demonstration, I'm going to choose the starter template. I'm going to keep the default smart contract name to Hello World. You can type in your name here and your email. And then I'm going to say yes to Python formatter. I'm going to say no to unit test to keep it simple. Yes to VSCode configurations. Yes for ESLinting. Yes for Tailwind CSS. Yes for Daisy UI. And no unit test and no end-to-end test for simplicity. And then it's going to ask you whether you want to run Bootstrap because I want to set up my development environment. I'm going to say yes to that because Bootstrap is going to install all the dependencies that you need to build your Algorand application. Once that's finished, I'm going to say yes to this so that it initializes my Git repository. Now, if you have VS Code as your default code editor, AlgoKit init is going to automatically open VS Code for you in workspace mode. Now, for some reason, if your workspace didn't open up automatically, just cd into the project folder and then open it up manually. Now, when you open up your AlgoKit project manually, it doesn't launch in workspace mode. But to fully utilize all the seamless integrations included in the template, such as running debug scripts, you need to be in workspace mode. So if you manually opened up your AlgoKit project, just go to the Fullstack Demo Code Workspace file, and then click on this button right here, Open Workspace. Now this is going to open up the same project, but in a workspace mode. When it's in workspace mode, you'll see that there are 3 folders, root, backend, frontend. And in your VS Code terminal, you'll see 3 terminals for each folder as well. Now the root folder has all the configurations for your templates, so you don't really have to worry about the root folder. So the backend folder and the frontend folder are the 2 folders that you need to learn what it's about. First, let's see what the backend folder is about. The backend folder is the exact replica of the Beaker template that we saw in the previous videos. So let me just extend this. Now all these files here are configuration files, so you don't really have to worry about them. But just know that the .env files include some environment variables, such as information about your local network and so on. But what's most important is this smart contracts folder. And inside the smart contracts folder, there's a hello world folder, which includes the default hello world smart contract inside of contract.py. And this deploy config.ts file includes the deployment script that instantiates the AlgoKit client, the indexer client, creates a new account in your local network, fund the account, create the application client for the Hello World application, and then deploy the Hello World application. And then if the application was first created, it will fund the application and then call the hello method down here using the application client. So when you're testing your smart contract, you can edit the deploy config.ts file to run deployment scripts that test all the methods inside of your smart contract. Coming back here, the helpers folder includes a build.py file. This file has the build method that will build your smart contract and even generate an application client for you during the process. And then this is going to automatically create the artifacts folder and write out all these artifacts inside of that folder. Now make sure you don't edit this file so that later when you run the debug script, it can automatically build your smart contract and deploy your smart contract. Coming back up, there's a config.py file, and this file detects all of the smart contracts that are within the smart contracts folder. So let's say if I have multiple smart contracts other than Hello World smart contract, then this file will detect all of them and make sure it runs all of the deploy config.ts file within those folders. And the index.ts file will run the deploy script. Now again, make sure you don't manually edit the index.ts file and the config.py file. They're both utility files that allows you to run debug in a seamless manner. Now let's build the Hello World smart contract and run the deploy config.ts file to see if everything works. Now before you do that, I like to go to my external terminal and then launch the local network. So you can do that by doing AlgoKit localnet start. Now let's go to our Docker desktop to make sure our local network is properly running. And you can see that they're all running fine. Now let's go back to our VS Code, come to the run and debug section. And then if you press this arrow here, you can see that there are 3 deploy scripts. One that will build and deploy Beaker application, one that will only deploy the already built Beaker application, and one that will only build the Beaker application. Now the build and deploy Beaker application launches the AlgoKit localnet in the process, but currently there has been some issues with this, so I just like to go outside, launch the local network before I run the debug script. So if you're facing issues launching your local network through the debug script, make sure you head back out to an external terminal, launch localnet, come back and run the debug script. All right, let's click this green arrow to start debugging. Now you can click this or you can press F5 to run the debug script. I'm just going to click this. Now as you can see, it's trying to launch AlgoKit localnet again, but since it's already launched, it won't do that. And then if you see over here, all these prints are from the deploy config.ts file. So if you go back to our deploy config.ts file, you can see that it's first console logging deploy hello world, which you see right here. And as you can see, it's funding the address over here. It's deploying the application here. And then coming down here, you can see that it calls the hello method over here and receives hello world, which is the result of this part of the code right here. Now going back to our file explorer, you can see that this artifacts folder is now created. And if I open that up, there's another folder inside of the artifacts folder called hello world, and it's got 5 files in it. The application.json, which is an extended API of your smart contract, approval.tl and clear.tl programs, which are TL source code of your smart contract, client.ts file is your auto-generated application client, and contract.json is the API for your smart contract. Now later when we go to the front-end folder, we're going to be using these artifacts to interact with their smart contract using a front-end UI. So you have to build the smart contract before you head over to front-end folder and start interacting with your smart contract. All right, so that's the gist of the backend folder. Just to quickly recap, The two files you will mainly be working with will be the contract.py file and the deploy.config.ts file. Now, obviously, you're going to be creating your own smart contract and not using the default Hello World app. So you can edit the code in here, rename the Hello World folder, and then edit the deploy config file to deploy and interact with your smart contract. And you don't need to do anything else to make sure the debug script work. The build.py file, the config.py file, and index.ts file will automatically detect your changed smart contract and properly build and deploy your smart contract using the debug script. All right, now let's go take a look at our front-end folder. Now, the front-end folder is an exact replica of the React template inside of AlgoKit. So the Fullstack template is a combination of the Beaker template and the React template. So down here, again, all these files are configuration files. And all the React code will be inside of the source folder. Now let's launch our development server and see what the default front-end UI looks like. So open up your terminal, go into the front-end terminal right here, and then run npm run dev. Now let's quickly see what that did right there. So when you do npm run dev, it's going to generate the app client, and then write that generated application client inside the contracts folder. So if you come over here and look inside of the contracts folder, now the hello world.ts, which is the app client for your Hello World smart contract, is generated. Now the existing code base already works with this Hello World application client. So let's take a look at the front-end UI. I'm going to copy this, go to my browser, and then paste in the URL. Now this is the front-end UI that comes with the Fullstack template. So let's see what it can do. If you click this Getting Started button, it will take you to the AlgoKit GitHub repo. And if you click the Wallet Connection button, it's going to connect to your local network wallet. So click Local Net Wallet. It's going to ask for the KMD password. Now, if you haven't set your KMD password previously, that means there is no password. So just click OK. And then it's going to connect with a wallet that exists on your local network. So as you can see, the address of the connected wallet is this, and the network is local network. Now let's try interacting with the Hello World smart contract. Click on the contracts interactions demo, and here type in the input for the hello function. So I'll say Chris, click send application call. It's going to ask you for the password again, click OK, and then it asks for it again, so click OK again. And then if you look down here, you can see that the response from the contract, hello Chris, is printed out. So just like that, right out of the box, we have a fully functioning Fullstack Algorand application that interacts with the Hello World smart contract. Now let's go back to VS Code and see what kind of components and the structure of this front-end UI looks like. All right, we're back in our VS Code, and let's go to the app.tsx file. Now, the app.tsx file is where all of the wallet integration is happening. So if you look at line 4, we're importing in all these things from Transaction Lab use wallet library. The use wallet library is a React hook created by Transaction Lab that makes Algorand wallet integration for a React project super simple. So you can see right now it's supporting dfly wallet, Para wallet, Daffy wallet, and the Exodus wallet. But right now we're on our local network. So you can see that if from the .env file, if the LD network is just an empty string, that means we're on a local network. So we use the KMD wallet, which is the local network wallet. That's why when we try to connect their wallet, we connect it to the local net wallet. Later, I'll show you how you can change to testnet mode and interact with all of these wallets right here. All right, coming down here, we have code that opens up and toggle modals, which are these things. And here we're initializing the providers, the wallet providers like this. And then down here, we're passing in the wallet provider like that. So everything inside of this wallet provider right here has access to the wallet provided by the use wallet React hook. Now going to the components folder, let's take a look at the connect wallet.tsx file. Now this component right here is what you see when you are trying to connect a wallet. So when you click wallet connection, this component right here is the connect wallet component you see over here. So this active address variable right here is from use wallet again. And if your wallet is connected, that means this active address is set to the wallet address. And if your wallet's not connected, it's just undefined. So over here, we check if the active address has a value, and if it does, it shows the account detail. But if it's not connected, it maps through the providers array and show all of the possible wallet providers that you can connect to. But if you're connected to LocalNet, it only shows you the LocalNet wallet option. Hence why we only see LocalNet wallet over here. Now when we click this LocalNet wallet button, it's going to return provider.connect, which is a method that will connect your wallet. So once we click this and click OK over here, that connects our LocalNet wallet. Now let's see what this looks like when we're on testnet. So I'm just going to log out over here, come back to VS Code, and find the file .env. Now inside the .env file, you have all of the configurations for LocalNet, testnet, and even mainnet. Now, to use testnet, what you need to do is you need to comment out all these code under LocalNet, and then uncomment everything under testnet configurations. Save the .env file, reload this page, and now when we click wallet connection, you should see the 4 providers that are available for you using the use wallet React hook. So going back to connect wallet, you're seeing these 4 options right here because we are mapping through the providers list right here. All right, let's try connecting to Pair-Wallet. And before you try connecting, make sure you create a Pair-Wallet or any of these wallets before connecting them. I'm going to go to Pair-Wallet, type in my password, connect, and there you go. My Pair-Wallet is connected on testnet. And if I try interacting with the contract, hello Chris. Now I'm going to have to pass in my passcode for my Pair-Wallet to sign the transaction. And it's going to make an application call. Click confirm. And then I'm going to get the response, hello Chris. Now testnet is public network, so it takes about 3.3 seconds for your transaction to go through. Now let's go to appcalls.tsx to see how the deploying of the smart contract and calling the smart contract actually works. So inside of appcalls.tsx, you can see that we're importing in the auto-generated application client from contract/hello world, which is auto-generated when we ran npm run dev. Inside the appcalls component, we're instantiating the AlgoKit client, the indexer client, and then let's first take a look at our JSX code. What you see right here is exactly this model right here. So say hello to your Algorand smart contract is written over here, and we have an input where on change is going to set the contract input. And the set contract input is defined up here using useState. And then when we press the button to send the application call, it's going to call the send app call method. And let's take a look at the send app call method over here. It's going to first set loading to true so that this button becomes a loading circle. Define the app details over here, where we have the sender is the active address, so the wallet that's connected right now. And if our smart contract is already deployed, we're going to find that existing application using our indexer. Now using the app details, we're going to instantiate a new Hello World application client over here and set that to app client. And then we're going to use this app client to deploy the smart contract. So you can do that right this, and we're going to catch an error if there's something wrong with the deployment. Once it's deployed, we're going to use the app client again to call the hello method, pass in the argument name as contract input, which is the input value that you pass in over here. And then again, we're going to catch the error like this. Now we're going to store the response inside of the response variable. And then we're going to use the snack bar, which was the green bar that showed up over here, to show the result of your contract interaction, which says response from the contract is the response. And the variant set to success means that the bar will be a green bar. So that's how the deploying and interacting with your smart contract is defined inside of your default full stack template. So you can reference this appcalls.tsx file to learn how you would implement the interaction part for your application. Now, because of time constraints, I'm not going to go over every single components inside of the components folder, but make sure you check them out, play around with it, change them however you like to get the feel of the full stack template and how you can use it to build your own application. But just to do a quick recap, app.tsx file has the wallet integration part, so you can see how you can integrate Algorand wallets to your application. The connect wallet.tsx file shows how the actual connecting part works. Appcalls.tsx is a great reference to learn how you can deploy and interact with your smart contract using the auto-generated application client. And the .env file is where you can change the configuration to whether work in a local network or with testnet. And you can do that by uncommenting the section that you want to work with. I hope this overview of the full stack template gave you an idea of how you would implement your own Algorand application using this template. I showed you how you can launch a development server and interact with the default Hello World application right out of the box without changing any code. I use this as a boilerplate to create your own smart contract, customize your React frontend, integrate your smart contract into your React frontend, and be on your way to make a fully functioning full stack Algorand application. Well, that's it, everyone. If you have any questions, head to the Algorand Discord channel to get your questions answered by the developer relations team or the Algorand developer community. Also, if you like this video, make sure to give us a like and subscribe to stay in the loop. That being said, thank you so much for watching. I'll see you in the next one.